We're now going to look at maximum and minimum problems. These are practical problems which are equivalent to finding turning points and their nature. Now, in these problems, we will have to set up an equation for a subject variable and another variable. So if we take a look here, we have an equation here which has a subject variable. The subject variable is the letter that is by itself and has a coefficient of +1. So y is the subject variable, and then x here is the other variable. Now the subject variable will have its maximum or minimum value at the turning point, and that happens when dy by dx is equal to 0. You'll then solve that equation, dy by dx equal to 0, to get the critical value for the other variable. In other words here, to get the value of x, which causes y to be a maximum. Once you've got that critical value of x, you then sub it into the equation to get the maximum or minimum value of y. And then you also sub that value of x into the second derivative to prove whether y is a maximum or a minimum. Now the same thing applies if the subject variable is not y and the other variable is not x. So for example here we have a and r. So in this case a would take its maximum or minimum value at the turning point, in other words where the first derivative is equal to 0. Now the first derivative this time will now be dA by dr because the subject variable is a and the other variable is r. Again, you would solve that equation to get the critical value of r, which causes a to be a maximum or a minimum, and then you would sub that value of r into the equation to work out the maximum or minimum value of a. Then you would sub the critical value of r into the second derivative to prove whether a is a maximum or a minimum. So it's very, very similar to just finding turning points and their nature.